November 13th. Okay. First things first, I did want to make the announcement that I just got your tests. That was a couple of hours ago. I will be trying to get them graded this afternoon. And the reason I'm trying to get them graded by this afternoon is if you are debating whether or not to withdraw from the course. The W deadline for any course is Wednesday. And so I want to be able to let you know your grades as of that point, so you'll have a better idea of what to do. What we will be doing for the remainder of the semester is we're going to be dealing with conversions. Specifically, we're going to be dealing with stoichiometric conversions, which is a fancy way to say chemical mathematics. It's what stoichiometry boils down to. We're going to start by doing some one-to-one conversions. And those conversions are going to grow. We're going to do some two conversion factor conversions. And then we're going to move into some balancing chemical equations. And finally, we will move into the majority of what is considered to be stoichiometry. But this week, my goal is to basically remind us where we were before the exam on so where we were last Wednesday. And to start getting us thinking about some of the other conversions that are possible, and then we'll go from there. And so I also know we'll be balancing chemical equations this week. So. Okay, so let's just look at the question that's up on the board. 12 grams of sodium carbonate contains how many 12 moles of sodium carbonate contains how many grams? The first thing you do is identify what you were given. We were given 12 moles of sodium carbonate. You identify what it is you need to solve for. We need grams of sodium carbonate. Then I said that you would start asking yourself questions. Does this contain atoms or moles? No, we don't need Avogadro's number. Does this contain two different substances? No, so we're not going to need a mole to mole ratio. Does this contain a mass unit? Yes, because it contains a mass unit, we're going to need the molar mass of the compound. So we have 2 sodiums, we have 1 carbon, and we have 3 oxygens. Sodium has a mass of 22.99, carbon a mass of 12.01, and oxygen a mass of 16.00. So the sodiums contribute, wake up calculator, 45.98 to the overall mass of the structure. The carbon contributes 12.01, and the oxygens contribute 48 to the overall mass. So the mass that we're dealing with is 105.99. That's 105.99 grams of sodium carbonate is equal to 1 mole of sodium carbonate. So if we start with 12 moles of sodium carbonate, what part of this equality that we just developed is going to go into the denominator? The 1 mole of sodium carbonate will go into the denominator, and therefore the 105.99 grams of sodium carbonate goes into the numerator. So we key that into the calculator and we get out 1,271.88 grams of sodium carbonate. Now to figure out the significant digits. We have two significant digits in our original number. The molar mass, we have 5 significant digits in the mass portion, and in the 1 mole, that is an infinite number of significant digits. Since our measurement with the fewest had 2, our answer can only have 2 significant digits, and therefore we would record this as 1.3 times 10 to the 3 grams of sodium carbonate. Yes.
I'm really sorry. Could you make it like a little bit bigger?
I will start writing bigger.
Thank you.
Yes.
If you would have written the answer as 1,800, or like instead of putting it into scientific notation,
This is also correct. 1,300 grams of sodium carbonate. Either one. Other questions? Okay, another example. Gotta remember to write bigger. This says 1.62 times 10 to the 26 oxygen atoms are in how many moles of chromium 6 oxide? 1.62 times 10 to the 26 oxygen atoms are in how many moles of chromium oxide? Okay, so we identify what we were given. We were given 1.62 times 10 to the 26 oxygen atoms. We were asked to solve for moles of chromium oxide. I need to do that. Okay. So, is the term atoms or molecules involved? Yes, so you are going to need Avogadro's number, which is 6.022 times 10 to the 23rd of anything, in this case, oxygen atoms, equals 1 mole of that thing. So 1 mole of oxygen. Are the two substances identical? No, so we're gonna need a mole to mole ratio. Where does the mole to mole ratio come from in this case? It comes from the formula. This formula literally is saying there are 3 oxygens in one chromium 6 oxide. So the mole to mole ratio is that there are going to be 3 moles of oxygen to 1 mole of chromium 6 oxide. Questions? I didn't mean to go there this quick, but we're going there. So when I begin the problem, I start with the 1.62 times 10 to the 26 oxygen atoms. What goes in the denominator of the equalities that I developed? It is the 6.022 times 10 to the 23rd oxygen atoms. Why did you choose that one?
Because it matched up with the, not matched up, but like we had the oxygen atoms at the end of the.
Correct. It was chosen because the unit and the substance has to cancel out. The other half of that equality will go in the numerator. I use up an entire equality in one conversion factor. But this leaves me moles of oxygen, not moles of chromium 6 oxide. So I'm not done yet. What goes in the denominator? Once you use a conversion factor, you will not use that conversion factor again. Why did you choose it? It is the 3 moles of oxygen because the unit and the substance have to cancel out. The other half of that equality goes in the numerator. Am I ready to calculate? How do I know? Because I got to the moles of CrO3, which is what it asked me to solve for. If the substance and unit left was not moles of CrO3, I would not be done. But because this is what I was asked for, I am ready to calculate. So 1.26 times 10 to the 26 divided by 6.022 times 10 to the 23rd divided by 3 gives you an answer of 69.74195 moles of CrO3. You are correct. Good ear. Let's see about this. How about 89.67? 89.6712. Now, sig figs, your starting value has 3 significant digits because there are 3 digits in the mantissa. Your first conversion factor, the moles in that conversion factor have an infinite number of significant digits, whereas the 6.022 has 4 significant digits. And mole to mole ratios are infinite numbers of significant digits. So since the measurement with the fewest had 3, our answer should only have 3. And therefore, we're going to report this answer as 89.7 moles of chromium 6 oxide. Questions? Let me give you a couple to work on. Okay, let's look at how it's going. On the first problem, what I was given is I was given 26.9 moles of S2O3. And what I was asked to solve for is moles of sulfur, or in other words, moles of S. One thing that I always do first, I don't go straight, typically I don't go straight to the atoms and molecules. I don't go straight to the grams. I go, are my substances the same? Is S and S2O3 identical with respect to their formula? No. So you are going to need a mole to mole ratio. And according to this, for every 1 mole of S2O3, there will be 1 mole of S. I'm sorry, 2 moles of S. 2 moles of S. A lot of times, if you come across something that has the unit you desired in it, you probably are done. So I would have started with the 26.9 moles of S2O3. And I would have used the fact that 1 mole of S2O3 contains 2 moles of S. So in other words, we're dealing with 53.8 moles of sulfur. And since that is what we were looking for, that is our answer. Questions? Let's look at the next question. I was given 29.7 grams of cobalt 2 chloride. Yes, naming can come back. 29.7 grams of cobalt 2 chloride. Cobalt 2 chloride is CoCl2. I was asked for the number of atoms of cobalt. Are the substances the same? No, so you will need a mole to mole ratio. For every 1 mole of CoCl2, there is 1 mole of CO. Does it contain the word atoms or molecules? Yes, so you're going to need Avogadro's number. So 6.022 times 10 to the 23rd of anything, in this case, cobalt atoms, equals 1 mole of that thing. In this case, 1 mole of cobalt. Does this contain mass? That means you're going to need a molar mass. So you are going to need 3 conversion factors. We have 1 cobalt and we have 2 chlorines. Cobalt is 58.93. Chlorine is 35.45. Adding those together, you get 129.83. That is 129.83 grams of cobalt chloride is 1 mole of cobalt chloride. Now we're ready to perform the conversion. So 29.7 grams of cobalt 2 chloride. My first conversion factor needs to have grams of cobalt chloride in it. So which one am I going to use? The molar mass. And of that equality, what's going in the denominator? 129.83 grams has to go in the denominator because you have to cancel the grams and the substance. The other half goes in the numerator. Now I have moles of COCl2. What comes next? You can't use the same conversion factor again. Once you've used it, you're done with it. So the mole to mole comes next. What part of the ratio goes in the denominator? The 1 mole COCl2 goes in the denominator. Why? Because the substance and the unit has got to cancel. You're now left with moles of CO. And again, once you've used a conversion factor, you don't use that one again. So we're done with the mole to mole. We must need Avogadro's number next. What of Avogadro's number goes in the denominator? The mole. The reason it goes in the denominator is because you got to cancel out the substance and the unit. And when we complete this calculation, we got to the cobalt atoms that we were asked to solve for. And the answer comes out to be 1.3776 times 10 to the 23rd cobalt atoms. Now we need to determine the number of significant digits. We have 3 significant digits in our starting number. In the molar mass, the mole portion is has an infinite number of significant digits. But the mass portion has 5 significant digits. In the mole to mole ratio, all mole to mole ratios will have infinite number of significant figures in the numerator and in the denominator. And then we were down to Avogadro's number. There are 4 significant digits in the top, and the mole portion of Avogadro's number is an infinite number of significant digits. Looking at this, the one with the fewest had 3 significant digits, so our answer needs to only have 3 significant digits. So you would report this as 1.38 times 10 to the 23rd. Cobalt atoms. Folks, the way I've been teaching you, if you can get that method down, is it the same substance? No, I need a mole to mole ratio. Is atoms or molecules involved? Yes, I need Avogadro's number. Is mass involved? Yes, I need molar mass. If you can get that down, you can do pretty much every single calculation that we will be doing conversion wise. Not quite all, but almost all of them. So for some folks, what I've been describing can be challenging and you would rather have a flow chart. I'll give you a flow chart. Now you want this flow chart on a separate sheet of paper because we will build on it at the very end of the semester. Okay. If I have the word atoms, molecules, or ions, what is my conversion factor? Avogadro's number. Which is 6.022 times 10 to the 23rd of anything equals 1 mole. Okay, that will allow you to convert to moles. What's the conversion factor that allows you to go from between two substances? A mole to mole ratio. The other thing that we had was grams. And what allows us to go to grams? Molar mass. Basically, folks, what is on the arrows is your conversion factor. You're okay. Now, let me illustrate how you use it after you get a chance to write it. I'll go ahead and finish it out so that you have it on the same sheet of paper. We're not doing this last piece yet. Okay. So on this last problem we did, what did I start with? I started with grams of cobalt chloride. Where did I end? Atoms of cobalt, correct? So the first conversion factor I used was the molar mass. Why do I know that? Because I started here. First conversion factor I used was molar mass. That got me to moles of A. And then I used the mole to mole ratio to go from cobalt chloride to cobalt. And then I used Avogadro's number to get to atoms of cobalt. So I used this conversion factor, that conversion factor, and that conversion factor on my way to the calculation. So if you're not one that gets the process, maybe this map will help you. So let's just look at something. If I say what mass of SiCl4 contains .96 times 10 to the 24 Cl atoms. What's my first conversion factor going to be? Well, where am I starting? I'm starting with Cl atoms. Here. So what's my first conversion factor going to be? Avogadro's number. Were SiCl4 and Cl the same element or same substance? No. So where am I going from here? Mole to mole, because I had two different substances. And what do I want? Mass, which is? Well, I'm going to need the molar mass to get to mass. So this is the three conversion factors you need. You need Avogadro's number, you need a mole to mole, and you need the molar mass. In that order. Depends upon how you work, which one works better for you. You now have two different ways that you can approach these problems. We're going to do a couple more of these, and then we're going to start balancing chemical equations on Wednesday. I will see you Wednesday. Go get some water.